Hi everyone, and welcome to my talk. So, thank you. Thank you very much. So, today we are going to be talking about the newest Java concurrency updates. However, let's get acquainted firstly. My name is Sophia, and I've been working as a Java developer for almost 3 years now. To be honest, I'm very nervous now. I just spilled tea all over myself, so thank God it's gone. But my point is, just don't judge too quickly. Okay, let's get it started, I guess. Let me ask you a question. Who thinks that working with Java threads has been a bit complicated? Just raise your hand. Oh, that's nice, yes. You see, and it also required lots of boilerplate code. You see, that's why today I'm going to be talking about only 2 single classes. Class completable future, added in Java 8 and updated in the 9th, and also class flow, added in Java 9. Let's see the value these classes bring into our lives. So, we'll start by looking at the updates that completable future provides. Firstly, this class is located in Java util concurrent package, although it should have been in Java base by now, but it's still in Java util concurrent. It implements a well-known interface feature, which contains only 5 methods, get and get with timeout, and the problem in here is that, it's a blocking approach, so we have to wait. It also implements like is done, cancel, and is cancelled. I'm not going to be diving into that because that's not the topic here, but it's a problem. This is not enough. Thus, it also implements interface completion stage, at which we are taking a closer look right away. So, Completable Future API offers more than 60 methods, and it allows us to perform more advanced operations such as chaining callbacks and building pipes, waiting for the completion of the future and manually completing the future, reacting and recovering from the exceptions, which was actually missing from the future interface that was with us from the 5th Java. So, the existence of such a strong API results in a brand new concept emerging in Java, a concept of promises. Promise means that the computation will be finished. The result of the computation will be provided, even if the computation fails. It also provides a non-blocking approach. So basically, the callback is attached, and you get notified when your computation is ready. Meanwhile, your code is not stuck. It continues doing some other tasks. So, let's just take a closer look in the API demo so we can see the bigger picture. Because besides a non-blocking approach, completable future has much more to offer. And we'll start with the canonical way of creating a new completable future. Method supply async. It takes a supplier, as far as we can see, and also returns a result. It will be an actual result, so an integer wrapped in completable future. But there is a problem, some pitfall in here. This is a very important use case. So, before I run the following code, could you predict in which thread this action will be executed? Maybe any ideas? Yes, it will be the common pool of fork join pool. Just let's run it just to be sure. Yeah, we have common pool. What's the downside of this? The disadvantages? Yes, sure. And then a situation where you have to wait can occur because the resources are exhausted. And also, there is one more problem because this is also a general purpose pool and we have absolutely no control over it. So we cannot even shut it down. But there is a solution to this problem. It's supply async method, but actually the overloaded variant of it. It's supply async that provides a custom executor parameter. So everything is the same here, but we provide an executor here. And let's just run it. And here we see that our action is run in pool 1 thread 1, but not in the common pool of fork join pool. But you just need to be aware of this issue, that you have to specify custom executor so you can avoid this common pool, this exhaustion of resources. And our next step will be creating a pipe. So now we know how to create a new completable future. Let's chain callbacks. In order to do that, firstly, we will be using here quoteUtil class. It randomly chooses the quotes from the completable future movie. It just simply reads the quotes from the resources files, but using a getQuote method. And that's the least interesting thing for us. So here we create a new completable future using supply async with custom executor parameter. We remember that. Then we use then apply. It accepts a function and returns also some result. But simply said, it just takes a future that was processed on the previous step and returns also a future for further processing. So we can chain callbacks, so we can build this chain, build this pipe. So we want to add a movie name to this quote, we want to count the length, and just print the result using then accept method. It takes a consumer, in our case, just to print the result to the console. Also, then accept method is a side effect method, so it returns nothing. In meaning of completable future, I say nothing when I mean completable future of void. So there is something, but we cannot further process it as we want. But I'm going to run it now. We printed this result, but of course, there is some pitfall in here. Maybe you have any idea. I'll just give you a little hint. So there can be a problem in here with the threads that our tasks are ran. Sorry, I'm sorry. Okay, is this fine? Our tasks are ran in. How do you think, in which threads were these tasks executed? For example, then apply, then accept. Come on, guys. It should be done before the talk. Yes. Okay. Okay. Let's move on then. Here the code looks a bit more terrifying, but so we perform all the same actions actually. We perform all the same actions, but using then apply async variant. Why am I showing you this? Because if we run this code, oh, not this one, yeah. So we're in this code and we see that new completable future has been created in pool 1 thread 1 because we specified custom executor, avoided common pool. Then apply the next one where we appended the movie name was executed in the same thread as the previous one. Then we used apply async. So it is pool 2 thread 1. As far as you can see, this method, they allow to perform our actions in different threads. So, but on the other hand, context switch should be taken into consideration, like there may be no thread available again and we have to wait. But if we want to avoid, if we want to control threads, we want to avoid blocking, we should use then apply async. My point in here is that method with the following signature, like then apply or then accept, can be ran in first the same thread as the previous task was executed in, like we've just seen. So we created our future in pool 1 thread 1, the next one was again in pool 1 thread 1, but the second action, the second use case here, it can be the main thread again. So what's the point in here? We're trying to achieve a non-blocking approach here, but we are getting main. It's really difficult to reproduce, so I created the screenshots. But why this happens, you might get this question. This depends on how fast our futures are executed. If the previous future has already finished, the new future will take place in some different thread, if we use then apply async, for example, or in the main thread, thus causing the blocking. So here, this is the issue that we need to be aware of. We should basically always keep an eye on the threads our tasks are executed in. But we will be moving forward with our demo. Previously, we have worked with then apply with some simple types inside. We were passing string because we were reading some quote from the movie. Take a look in here, please. So inside then apply, we are trying to work with the completable future too. So my question is, if I want to create a local variable in here, what will the type of this variable be? Because there is a pitfall in this too. Any ideas? Okay, I'll just create it then. It will be terrifying. It will be completable future of string. Of course, we don't need these nestings, but unfortunately, then apply does not understand that. So the solution is actually simple. We just need to use a different method for that. It's then compose, which knows how to handle these nestings. And here we see that it is completable future of string here. And we'll just print it. Oh, yeah, I just missed something in here. Okay. Yeah. So, but my point is much wider than use then compose instead of then apply to avoid these nestings. It is just one of the use cases. Just please try to use as many methods as possible so you can explore the API, so you can see that there may be a solution to your problem. Up to this point, we were working only with one future. But what if we want to execute a bunch of them? And sure, completable future API provides us with such an opportunity. This is the method all-of. And here, I emphasize your attention then the all-of, it takes just the futures to be executed. But here, these arguments are of different types. I mean, quote is completable future of string. And quote is completable future of list of strings. So we will get our futures executed. The future will be completed. But if I want to introduce a local variable here again, how do you think what the type of this variable will be? What can we get as a result of this computation? I give you a hint. Of course, it will be completable future of something, but oh yeah, I have two answers in here, and the right one is, who said void? A lot of people, yeah, it will be void. It is a side effect method, that's why it will be void, because it does not know what to return in here, and this method concentrates more on the completion of all the futures, but not getting the result of them. If we want to get the result, we just, after that, we must do some ugly stuff like getting that manually. But the point here is that when we want to execute a lot of futures, we need to remember that we won't get the actual result. We'll just get them executed. And I heard one more answer, and it's applicable to a very similar, I say, use case. For example, we have many futures, but we want to wait only for the fastest of them to complete. For example, if they are calculating all the same value, but differently, like with different algorithms. And of course, the answer was already given. Any of in here returns So void because then except is here, but actually any of returns completable future of object. So here I gave you a hint, so then except is being used so that we can actually see the result. I'll just run it. So it is the quote from this movie and we successfully got it. But the point is that on the contrary to the all of, any of returns completable future of object, although it accepts all the same arguments. But here we are more looking for a result, but not the computation. And yes, the last pitfall, because I was very much alike with this girl on the picture when I was preparing for this presentation. So, no secret is that exceptions can happen. And let's have a look how usual exceptions, usual completable future methods, can handle these exceptions. For example, then apply, our favorite then apply. What we are doing here, we are trying to provoke a null pointer exception by submitting an empty quote. I'd say more accurately a null quote. After that we are trying to count its length and print the result and, well, just to build a chain. I'm just gonna run it and we will get the exception. Here we have null pointer exception, but it is wrapped in execution exception. The deal with completable future is when you work with exceptions, you have to get completion exception, specifying null pointer exception, but not execution exception. It is wrong because we did not expect this exception to happen, so it should be completion exception. It is one of the use cases. And you can ask, why do we need this get here? It should be a non-blocking approach. But if I just command this get and run it, then it will be it will blow our minds because everything will perform successfully, there won't be an exception. Basically, it's because our lambdas won't even be executed and the exception will get lost somewhere on the way. So this is completely wrong. You see why it is, I think. So, exception handling is tricky, but completable future deals with that too. It provides us with a few methods that can provide not only exception handling but also recovery. These methods are handler, exception handler, that's the method inside of this is handle. Everything in here is quite the simple null pointer exception, but we use handle so we can work with this exception correctly. Maybe you can already see the downside of this method. What is the disadvantage? Well, we always work with two arguments in here, and we need this boilerplate if-else, when really at each step we're gonna use only one of them. If it's a result, then we'll get to the result. If it's a throwable, it will be an exception, but at least it works correctly. We have our null pointer exception wrapped in completion exception as the completable future contract states. And we have our handling, no quote available. But we can also avoid this boilerplate if else by using exceptionally, which accepts only one argument and provides also a recovery. Because it is not so boilerplate code, we can use it on our each chain. Oops, sorry. Yeah, and like deal with that without these if-elses. So I know I promised it was the last pitfall, but there is one more thing. And I know it does not sound as fabulous as on Apple presentation, yes, but well, this one more thing is called Java 9. So let's dive into Java 9 concurrency updates together. And as JAP 236, like Java Enhancements Protocol says, that it provides enhancements to the completable future API. They are considered significant as the support for delays and timeouts was added, better support for subclassing, making it easier to extend from completable future, and also a few static but important utility methods were added. So let's just dive into that by starting with time-based enhancements to the completable future API. Firstly, or timeout method was added. This method simply completes the future exceptionally with timeout exception, unless it is completed before the specified timeout. I know, too much words, let's just dive into the code. So, what we have here? Firstly, we wanna wait 5 seconds tops, so we specify how much we wanna wait. Secondly, we use an incomplete future and one complete future. After that, we wanna combine them into one by using then combine method. The principle this method works by is also very interesting. It waits for both of the futures passed to it to be already completed, to be already finished. But here we have one incomplete future, so we will be stuck forever. Of course, if we won't use or timeout method, which says that if in 5 seconds our computation is not finished, please let's get a timeout exception. And let's run it. Oh yeah, let's run this one. We are waiting for 5 seconds because this is the timeout. And finally, we can see that we get exception recovery. Sorry, timeout is 5 seconds. And also, just to show that there is timeout exception, but wrapped in execution exception, not in completion exception. Previously, I said that we should have completion exception. Yes, here it is a different case, because here we are expecting that there may be an exception, so we handle that this way, that because or timeout, it will produce an exception in case the computation is not finished. But that's not it regarding timeout support. We can also avoid exceptions when completing our future on timeout by using this method. The only new parameter in here for us is value. Basically, it's just a default value that is returned if in our specified timeout, if in 5 seconds our value is not completed. Well, let's just take a look. Yes. Simpler in here, we created an incomplete future and saying if in 5 seconds it isn't finished, please return us a default value. Waiting. And finally, we are getting our default value. So this is how the support for timeouts is actually added in Java 9. And that's it regarding timeouts, but there is still a lot of interesting stuff ahead of us. In Java 9, there was one more method, important one added, complete async. It provides, it states that our computation will be finished asynchronously by using the value provided by the supplier. Before this point, we had only complete, which was synchronous, and we actually needed that very much. It looks really familiar because it reminds us of a supply async, I think, because it looks just the same for me, but here we're getting complete async. And again, we completed this value asynchronously, specifying custom executor, avoiding common pool. But there is also this variant without custom executor parameter. And a question for you is, I already say that I need to specify custom executor to avoid common pool, but can we use this complete async method without custom executor parameter, but still avoid common pool? Yeah, it comes with Java 9 and it comes with subclassing support. there is a default executor method. It basically returns the executor you specify. It is a so-called default executor. But firstly, in order to achieve this, we must extend completable future. Secondly, we provide the executor we want to use everywhere. It will be used in all asynchronous methods if no custom executor parameter is specified. So if we use complete async in here without custom executor parameter, and this method, default executor, is overridden, then we will avoid common pool. Basically, as we know, it should have run in common pool, but now we have our default executor. And that's not it regarding subclass and support, because there is one more method, new incomplete future. It is a virtual constructor. It simply returns a new completable future instance of the same type. I'll just show you here. I know it's a lot. So, new incomplete future. Return in here, new custom completable future, the instance of our current class. It is very useful when subclassing. Do you have any idea why? I'll just give you a hint. It helps internally, yes, because many completable future methods use this new incomplete future internally, returning completion stage. And when we extend and when we override this method, this gives our subclasses better control of subtypes being returned. So simply put, it just gives more control over the types being returned. I know that's not so obvious from the first sight. And also, completable future tried to introduce some defensive copying mechanism. I tried to achieve it with the copy method. Well, this method, it works by a very simple principle. If the original future is completed normally, for example, with value of 20, then the copy will be completed normally too, also with the value of 20. If the original future is completed exceptionally, for example, with some null pointer exception, then the copy should be completed also with a null pointer exception, the same result. And the point here in defensive copying mechanism is just to give this copy to the client, but not the original. So you get the control of the original. And that's not it. We can also use minimal completion stage. It works the same as the copy, but there is one significant difference. Copy returned the completable future, the original one. But minimal completion stage, you can guess from the name of this method. What does it return? Completion stage, yes. Basically, it just cutting off the functionality that the client can use, and cutting it off really significantly. But we can always convert it back to completable future, so we can give client more control. And that's it about, that's all the non-static methods added to this API in Java 9. There are a few important static ones. And we'll start from the support of delays. The support of delays is reached by method delayed executor. It simply waits for the specified delay that you give, for example, for 5 seconds, and then it submits your tasks further to the base executor. So your tasks will be executed. I'll just show that in the code. Nope. So here we are completing our future asynchronously, but we want to have a little delay, a delay of 5 seconds, and then just print it to the console. And here we are waiting for 5 seconds because we are using a delayed executor, and finally printing the result. So this is how the delay support is achieved. Again, custom executor parameter can be specified here or not. And there are also few utility methods, completed stage, failed stage, and failed future. Well, we'll just review them superficially. These methods returned already completed or failed stages or futures. So that can be very useful for testing, for example. And that's it, folks, about completable future. Finally, I see. But we say it brings non-blocking approach to Java, yeah? Can we say that non-blocking is somehow related to responsive? Somehow related, yeah? And maybe you can guess any other components I'm trying to show you here, like message-driven, and then elastic, and resilient. And this should remind you of reactive streams. This is the reactive manifesto defining. And we'll just dive into reactive streams now because they are also considered a part of Java enhancement updates and in interoperable publish-subscribe framework. And it is implemented in Java using class Flow. The Flow API is a mix of push and pull programming models, basically the iterator and observer patterns. And it encloses primary building blocks for building stream processing logic. And we're just going to review these blocks. These blocks are represented by a few abstractions. These abstractions include publisher, subscriber, subscription, and processor. Let's have a look at each of them, and then we can build a bigger picture, so see how they interact with each other in Java's implementation. So we'll start with the publisher. Publisher is an asynchronous producer of messages for subscribers to consume. It has a concrete implementation. Why? Because usually publishers are very complicated to implement. They must follow multiple rules defined in the reactive manifesto. So it's better to avoid implementing them by yourself, but try using default implementation. And Java provides submission publisher. We'll look at it a bit later. And the most important method in here is subscribe, which adds a given subscriber. This is how we pass to the subscriber. Subscriber is an receiver of messages that publishers produce. Typically, it's the end of every processing flow because it does not send messages further. You can think of it as a thing where items are received but not processed further. It subscribes to publishers and it starts receiving messages. Here it is what's interesting. When it subscribes to publisher, it also requests some amount of items. So we can see the pool model in here. But then when a publisher starts producing the items, there is a bit of a push model in here because when a publisher calls submit, it also calls on next method that when subscriber signals that it is ready to consume more messages. In case of error, the onError method is invoked, and if publisher stopped sending messages and subscriber is through, it received everything it wanted, onComplete method is called. You may get a question how these two are connected. So we have publisher and subscriber. What's the link? And the link is subscription. It is a connection between publisher and subscriber. It is a message control. It allows subscriber to subscribe to publisher and request the items. And also subscriber may cancel at any time. So subscriber is more in control of everything that's happening. There can also be a combination of publisher and subscriber. For example, when we want to transform an incoming message and pass it further. So we can use processor interface for that. It acts as a subscriber because it receives messages. And it acts as a publisher because it processes them and sends them for further processing. And that's all for these components. So let's see how it all works out together. It all starts with a publisher. We use submission publisher, as I've already mentioned. Then we need a subscriber. We subscribe our subscriber with publisher subscribe, so the subscriber is added. After that, publisher calls onSubscribe method before the processing even starts. Here we see that subscription is passed as an argument, thus coming here as a class that is in control of our flow. And also, at some point in time, usually in this onSubscribe, a few items can be requested by using request of amount of messages. And basically that's it for the onSubscribe method. The initialization of subscription, and thus subscriber can store the subscription, and requesting the first portion of data. After that, onNext method is called. When publisher produces new items, it triggers onNext of the subscriber, and subscriber can either say that it's ready to receive more messages, or it's not. And this way the message flow is driven between these two items. We also need to implement onComplete. So when the publisher stops sending messages, the subscriber knows it's done. The subscriber has received everything is needed. In case some exception happens, the error method of subscriber is called to handle it properly. I know that's a lot to take. That's why we'll just have a look at publisher, subscriber, and transformer processor. Sorry. Okay. I think we'll start with the subscriber in Java 9. So, in order to implement our custom subscriber, we need to implement subscriber interface. Thus, we need to store an instance of subscription here, and also we are introducing a list of consumed elements, so the received elements are stored in here. Then, we implement onSubscribe method, which is called before the processing starts. The subscription is initialized, and the first portion of data is requested. After that, we are gonna implement onNext method, which in our case here simply receives the items, adds these items to the list, and requests more. And onError and onComplete methods implementations are really trivial in here, so we won't stop. Okay, and we'll just look at transformer. As I said, a transformer acts as a subscriber and as a publisher. That's why we need to implement submission publisher in here. And store the subscription, and also a function happens in here. A function is basically a transformation we want to apply to our items that are received. So we initialize our transform processor. We implement onSubscribe, as we've already seen, because it's the element of subscriber and nothing happens there. No processing, just receiving. And onNext. Here is actually where our transformation is applied. So this method is an element of a publisher. It's a publisher submit call. And by using this method, we can apply our transformation to the received item. We applied it, and then we request more. Again, onError and onComplete are trivial in here, but one more point, onComplete in here, it should close the publisher, because we are extending publisher in here, and we are responsible for closing it. And we should not forget about that. And we'll just look at how it works. Oh yeah. So the test that simply transform an integer of 1 to a string of 1. Just the simplest example. So here we have our publisher, and we have our transformation a function. We'll just convert it to string this way. We have our transformer, and you may recall that we created a constructor that was passed a transformation. So our function is passed here, so it can be applied in onNext method. And again, we'll just subscribe the publisher. When subscribe the subscriber, we're gonna call publisher submit for each of these items, and we're gonna close a publisher, because when we work with the publisher, we are responsible for closing it, and that's it. Maybe any questions regarding this test, or because there may be a question why thread sleep is here. Actually, it's a very bad practice, but I just need my test to wait. But don't do that. And here we have received all 3 items, and they are strings. And the last, but not the least, it was the demo. We will be using these subscribers and publishers to control the demand. No secret is that back pressure problem occurs very often when working with the reactive streams. Do you know what back pressure is? Yeah, no. So it's basically when publisher produces too many messages, so the consumer cannot handle them. And this problem is pretty solved in Java 9, because at each point we were controlling the amount of items we receive. But just for an example, we'll say we want to subscribe only one element. So this is a subscriber who is responsible for that. We create single item subscriber. We create a variable that is responsible for the amount of messages consumed. It's atomic because we're working between different threads in here. We are storing the subscription, and again the list. Initializing our subscriber, implementing unsubscribe by initializing subscription, and requesting the first item. After that, the onNext method is more interesting in here. We receive the item, add it to the list. And after that, we check if we want to receive more messages or we don't. So if our value is not yet reached, we request for more. If not, then we just stop. And then the publisher will be closed and this flow will be ended. So this is how the demand control is done. Just the basic. And okay, someone's taking a photo. I'll just thank you. And we'll just test that with a test that says that it wants only one message to be consumed. So we create a publisher in here, then our specific subscriber, subscribe with the subscriber, with publisher subscribe. We introduce the list of items that should be produced and the expected result that we only want to consume one item. We are submitting these items and closing the publisher. And we'll just run it. We are expecting that we want to get only one item in here. And yep, we received only one item. Maybe any questions regarding back pressure, because it's a common problem. Okay. And basically, after this demo, I wanted to show you that we can, the Java solution is actually applicable for solving a lot of common problems. And that's it for this talk. And I hope that after listening to it, you can understand the input that the latest Java versions make to the whole language, because Future was not updated since the 5th version, and we got updates only in the 8th. And reactive streams, which were existent for a long time in different implementations like Akka streams or Java Rex, they are just emerging in the 9th version. You can avoid the pitfalls. The common pitfalls that can occur when, not only when working with completable future, but again, when working with concurrency. You will decide to go reactive and actually to use the last and latest version of Java. I thank you very much for your attention. We have a perfect 5 minutes for questions. Thank you. Or we can just talk after this presentation. You can find me at my mail and my GitHub, where all the examples and even more of them are stored, because there was not enough time to show everything. Thank you.
Thank you for nice talk. Why we should use Java 9 instead of Java Rex? Because it is, I think, very complicated to re-implement all things that already implemented in these libraries.
Yeah, sure, but here we don't need to add some external libraries, and we don't know what's going to happen with these libraries, where will the support continue. But in Java we have it out of the box, so it's already in this language. We have some guarantee that it will be supported. We can use it, so it won't be in the next version of Java, it won't be simply out of use, out of date. I think so. For me, it's preferably Java. Yeah.
Basically, a question regarding the subscription process and requesting the new portion of data. Is it possible to handle the situations when a publisher will not give us a new portion of data in some time? Is it like, can we just pass the timeout for it, for the request?
So you mean like if we request the item and publisher is not sending?
Yeah, and publisher is not sending for several seconds, minutes.
Mm-hmm. Okay, I have not found the support of timeouts yet in this flow, but I think that maybe we should check if the publisher is closed, or the publisher may be hot or cold. So if it's hot, just publishing the items all the time, or if it's cold, we need to request them. So no support of timeout at this point, or I did not find it. Thank you. Very nice question. And I think that's it. We're done with the time.